This conference will now be recorded. This conference will now be recorded.
Okay, so but before we get into the details, can we have a quick understanding of what is the background for each one of you and how are we actually going to start, right? Because I want to understand the background so that we can actually start at the right logical point. So can we go with a simple 30 seconds intro from everyone? Anyone can start. I can see Vamshi Reddy on the screen.
Yeah. So hi, this is Vamshi. So currently I'm working as an automation engineer. So I just want to take this course to improve my skills on Devops and
How much
scale making.
experience you have, Vamshi?
Currently I have 3.5 to 4 years of experience in automation.
Automation. Okay, good. And when you say automation, what kind of tools you're using?
Currently, I'm working on Selenium
Okay,
and
good.
Cypress, and
Okay.
I also use some part of Jenkins. I connect to hives and all these things, but I'm not familiar with hive on all these big data things, but I just use
Okay.
those as a part of my developers explain. So
Okay.
yeah, so I can create some jobs and run those in Jenkins.
Okay.
So
That's good.
that's where I know, and I'm planning to move to DevOps career rather than sitting in here.
Okay, good.
Yeah.
That's a good start. Okay, thanks, Vamshi. Next.
I can go next. My name is Vera. Are you able to hear my voice?
Yeah, Veera. Yes.
Hi. Hi. I have around 3+ years of experience in IT industry. Throughout
Mhm.
my career, I work with various Java and J2 technologies like Spring, Hibernate, and REST-based web services. And
Good.
I work with various application servers, and I also work with various databases. And
Mhm.
and I have experience working with build scripts like Maven and continuous scripts like Jenkins. Yeah.
Okay, good.
Background. I'm completely on Java background.
Okay. Okay.
More and interested to work with the Devops as well.
Okay. Okay.
Yeah, that's
Good.
it.
Yeah,
Yeah.
that will be a good start. Okay. Thanks, Veera. Who's next?
Hi, this is Mallikarjun.
Yeah, Mallikarjun.
I'm working in Kia plant Hyundai Glovis Anantapur.
Mhm.
I am the IT department HOD, head of the department of
Mhm.
IT department. I have
Okay.
12 years of experience in Java, so I have to learn about how DevOps will work for our organization. So that's why I'm looking to this demo. So whether it will be fit to our organization or not.
Okay. Okay.
So
Okay.
that's what I'm planning.
Okay. Thanks, Mallikarjun.
Okay, okay, thanks a lot.
Yeah, hi, team. I'm Sai Kumar here.
Yes, I.
Total have 8 years of experience and 5 years into storage and 3 years into production and Linux server engineering. So right now I'm working as a part of DevOps, but not totally complete. Like we'll do like change activities and everything, like patching and everything. So
Mhm.
we build like Jenkins and GitLab, but I'm not sure how it runs. But we build the Jenkins how to do, and we create the Jenkins. And
Okay. Good. Yeah. Who's next?
Hey, hi. Hi, this is Praveen.
Yep.
So, yeah, I have 8 years of experience as a production support engineer. I work for Bank of America. So,
Mhm.
I want to learn about more into DevOps side of implementations and deployments. Yeah.
Mhm. Okay. So Bank of America production support in the sense like you are like L1, L2, L3 or
I'm
like
L3
what?
support.
L3 support. Okay. Okay.
Yeah.
So you have access to code and you are able to debug and all.
Yes, that's correct.
Okay. Okay. And who's next? I see. I think
Hi,
Prasad.
hi, I'm Dehay.
Okay. Yep, sir. Yeah.
Can you hear me?
Yeah, we can.
Yeah, I'm DH's professor. I have total experience of 5 years and I'm
Mhm.
into mapping from 5 years. At present,
Mhm.
I want to change my career to IT so that I'm taking this training.
Okay. Got it. Okay. Thank you. Next. Yeah.
Hey, hi, this is Madhu. I'm having 8 years of experience. I'm a full stack developer, Java. But just I
Mhm.
would like to upgrade my skill with respect to that, this CICD pipeline and
Okay, good. So you have a complete Java experience.
yes, yes.
Okay, good. And you're using like the Spring Boot or anything latest, or you're using the core?
Yeah, we use Spring Boot.
Okay. Okay, okay, good. And next, I see who did not speak is like Vandana. Vandana, can you hear us? And Sushmita?
Yeah. Hi, this is Susmita.
Yes. No.
Yeah, I have 2.5 years experience as a Java developer. Later, I took a break as a maternity break. And now I want to rejoin back. That's why I want to learn development.
Okay. Okay. Good. And someone, okay, so Vandana, we did not hear. Z, someone says Z. I don't know.
Hi, good morning, all. This is Shiv Kumar. So, I have a background of Oracle Apps DBA, have an experience of 8 years of experience. So, just want to know about DevOps, how it will be useful for me.
Okay, so you are into Oracle Apps.
Yeah.
And how long? Sorry, I missed it.
8 years of experience.
80 years in Oracle Apps. Okay,
Yeah.
okay, good.
Yeah. Yeah. Thank you.
Okay. So I think a couple of folks did not speak. Like, is anyone? Okay, I think now we see Vandana. Okay, yeah, Vandana, go ahead.
Hi, all. My name is Vandana. I have an experience in US healthcare sector for 5.8 years, and I just want to restart my career into IT field. I just want to grow up my career as a professional.
Okay.
So that's the reason I just want I'm into a DevOps.
Okay, got it, Vandana. Okay. And one more, someone who says Z.
Hi sir, this is Manikanta.
Yeah, sorry, Manikanta, you're also missing. Yeah, Manikanta.
Sir, right now I'm working as a detailer. Basically, I'm from outside mechanical engineering. 4 years I'm into mechanical only. Right now I'm planning to switch my career to IT by learning this DevOps and.
Okay, okay, good.
Yeah.
Good. Anyone left? Okay, so I just wanted to get a sense of what kind of audience we have. Okay, it's a mixed pack, of course. Like we have people who's completely new to IT and wanted to get into IT, to seasoned, experienced folks with around 8 years or somewhere close or more than that experience in IT, like maybe someone who knows in and out of IT is there. Okay, so what I'm going to do is I will start with a quick intro on how the software is going to be developed, why DevOps, why do we need it, okay? And then we'll get into the details around how DevOps is going to help this entire agile development practices and all this stuff, okay? So those who have experienced on all these things, bear with me for 10-15 minutes so that I'll actually make sure the newbies are able to understand where we are getting into, okay? Or you can help me, of course. Okay, so let me start sharing my screen, okay, and then we'll be able to get into the details, okay. So you all can see my screen, right?
Yes, we are seeing.
Okay. Now, okay, so what I'm going to do is, anyone who wanted to get into IT, okay, what do we do in IT in general? Okay, it's just like we build software, right? Okay, and we call building each of this software a project, right? In general, usually any field, okay, whatever they do, they call it as a project because they need to have a lot of governance around it. So we build projects, of course, software projects. But how do we build projects? Okay, what is the process behind building those projects? And for just like any other organizations or any other field, IT has something called software development lifecycle. Okay, so if you just go to Google and then just say SDLC, okay, it will give you the complete software development lifecycle phases, right? So for anyone who wanted to get into IT, they need to understand how software will be built. And for that, the basic thing they need to understand is software development lifecycle. Anyone, you can pause me if you are not understanding, okay? Or if I'm going too fast, just raise your hand or just speak out and then I'll stop and then take it slow, okay? So SDLC, software development lifecycle, is the first thing you need to understand. Okay, good. So SDLC is nothing but various phases. Okay, usually what we will leverage to develop a software. Okay, like you can just look into any of these diagrams and then it will give you like various phases. Typically there are 7 phases. Okay, so for example, you got a new project for your company. Okay, so let's say you are an IT lead or someone who got a new project that is awarded to you. Okay, so where you will start? Okay, so first obviously you will be starting with requirements, right? Okay, so you will be starting even before requirements. There will be a lot of phases, of course. Okay, um, that's why I'm just skipping that because it's not related to IT, because there will be a lot of other business stuff that will be going in before. So in general, these are the typical SDLC phases, what you're seeing on the image here, right? So you will start with the requirements. That means what the client needs. So you will go to the client, you will go to the end users, collect all the details that what kind of expectations they have on the functionality and features of the product that you're going to deliver or the project that you're going to deliver. Okay. So first thing is you collect all the requirements. Second thing is you will be here, it says defining, but a lot of people say analysis. Okay, so basically you will have analysis of all the details. Okay, basically, okay, you have thousands of requirements from your customer. How will you analyze all these things? Okay, or how will you put them together in various buckets? Maybe for your modularization or for your basically backlog prioritization, what we call it as an agile. Okay, all these things will be done. So next you will be designing the software. Okay, so you got all the requirements. Okay, then you need to design how your software should look like, of course on a paper. Okay, and then you will start coding. So you will start developing that project in whatever the language that you have chosen. Usually you will choose the language which will be best fit for those kind of requirements, because the requirements may not be only functionality. You will have always something called non-functional requirements, like how many users will be using this, what kind of infra I need, and what kind of compute I may need. Can it scale beyond some set of users? Okay, if I have like 1,000 hits for a day, it will be a different story versus 1,000,000 hits per an hour. Okay, so you need to have those kind of scaling, okay, in your project. So accordingly, you will choose the right language and then you will start coding in it. So once coding, the next thing is, of course, is testing. Okay, so once tested, okay, then you will probably get into the production or the live, okay, which is nothing but what we call as deployment. Okay, so the deployment is nothing but here into the production environments, even though we do deploy into the test environments. Okay, but typically the deployment is known into production environments. Once your code is into production, then it is called maintenance. Okay, so that's the standard phases. Okay, so you can forget about, okay, do I have 6 phases, 5 phases, 7 phases? Okay, doesn't matter. But this is a typical sequence of steps that we need to take care. That means, okay, so basically someone has given an elaborated view, okay, of what we will do here and all this stuff, right? Okay, so planning, analysis, design, okay, implementation or coding, whatever, testing and integration, okay, and finally you will have deployment and maintenance. Okay, these are the typical phases. Now this is the way that we will develop any software project, but in this SDLC there are different approaches, or we call them as SDLC models, methodologies, whatnot, right? So that is where you will see the importance of DevOps in the latest trends. Okay, so for example, if there are various methodologies, one of them is actually waterfall methodology. Okay, so I'll give only 2-3 methodologies. I will not go through each and every one. Okay, so the waterfall methodology, okay, is typically will look like this. That means all these phases, you have a project, you will collect all the requirements, then only you will move to the designing of that particular application. And once you complete all the design, then only you will start coding. And once you start, like, complete all the coding, Then you will start testing and final deployment, maintenance, whatever. Okay, this is the initial model. Okay, how we used to develop software, and this is most famous model. Lot of product companies still use this, right? But what is the disadvantage of this particular model? Okay, one simple disadvantage is that if you have a larger organization, okay, testing team will not be doing anything when there's coding getting on or requirements is developed or design is getting done. So at any point of time, only one team will be effectively working. So it's a lot of waste of resources and time and energy. That's the first thing. The second thing is from an end user perspective. Okay, if I want to see the results of my project, I will not be able to see anything in between, but only at the end. Okay, so let's say a typical IT project will take 2 years. Okay, a larger project I'm saying. Okay, can I wait for 2 years and then see what I have asked for is getting delivered or not? Sometimes the requirements may change in these 2 years, or sometimes there will be a lot of issues, or it may not be as expected. And again, it will go through loops of bug fixes, enhancements, and whatnot, right? So that will be a painful, and user will not be happy. Another disadvantage is that there will be a lot of competition in the current industry that will be taken over by your competitors. Okay? If you actually delay your product release for so long, that is a disadvantage of waterfall model. Okay, good. Now, what is the solution for this? Okay, so a lot of our consulting companies came up with a modularized development. Okay, where they said, okay, let's say you want to build a car, we will not build a car altogether, but we'll give a one module at a time. Okay, so let's say you have a project, we give UI working at one time and different module working. Like maybe you have 4 modules in a application, like you have an admin module, you have a user module, you have a lot of other modules, right? Okay, so we'll give one module at a time. So that modularized development came into picture. Okay, so in that modularized development, what's going to happen is they will follow the same stuff, okay, but one module at a time. Okay, so that technique was actually called as spiral model. Okay, so and a lot of people have implemented, especially the consulting companies have widely used it, okay, in various sectors. Okay, so which is actually going to help them. So spiral model is nothing but you divide your entire project into some modules, like 4 or 5 modules, whatever the how many modules what you're comfortable with. Okay, then they will go through the same waterfall model for each module. So that means they will start one circle. So one circle completion means one module got delivered. Okay, so second circle for second module, third circle for third module. Okay, so that's the way that they started delivering projects. Good. So it is little bit better than your standard waterfall model, but the disadvantage here is also that you are not giving an end-to-end working model, okay, for the clients. For example, if you are asked to deliver a car, you are delivering engine separately, you are delivering tires separately, you are delivering body separately, but when will you assemble all these things? Only at the end. Okay, so that's one of the disadvantages. And of course, spiral model sometimes will give you some modules which will be working, but that will be targeting to only one set of users. Not all the set of users will be able to use it. Okay, even at a lowest feature possible. Okay, that's one of the disadvantages in the spiral model. Of course, this reduces your cycle time from 2 years to 6 months, but at least once in 6 months, users can see something that is getting delivered. That will build the confidence, and then that will actually save some of the market also. Okay, but still it is not an optimized way of actually delivering the projects because of the current business the way it is. For example, I'll give you a telecom example. Okay, so Jio announced some drastic price drops in the launch, right? What about the competitors? So the moment Jio announced something, okay, Airtel and other competitors, okay, are supposed to adjust their rates and prices, okay, and they're supposed to launch some new products also, right? How is it possible for Airtel to really make sure the market is not going away, okay, by these new offerings, unless until they are able to deliver these projects like in a very quick manner. Okay, so within days or weeks, actually they're supposed to deliver. Okay, so in this kind of scenarios, okay, is your waterfall model going to work? No. Is your spiral model going to work? No, because it's going to take months and years. So that's where the agile has come into picture, where in agile, okay, the delivery time in general would be more than, like, not more than 4 weeks, like 2 to 4 weeks is what we call it as a standard sprint. Okay, so this entire process, of course the process is same, okay, but this entire process is accelerated to deliver a minute piece, okay, or a small piece which will be working independently, of course, okay, to your users. Okay, that will actually help the users to make sure they are competitive enough in the market. Okay, so 2 to 4 weeks is a standard sprint cycle that we use in agile. For example, this is the standard way of using agile. For example, you'll collect the requirements, design, develop, test, deploy, review. The cycle is same, it's not going to change. Okay, but from 2 years it came down to 6 months in sprint or spiral, and in agile it came down to 2 weeks. Okay, as less than as 2 weeks, right? Okay, of course there are some companies who will deliver in 1 week, or some companies that seamlessly delivering, okay, within 3 days also. Okay, that's a different story. Okay, so but agile, good. Now the question is, this is the current standard, and I'm sure many of you are already aware we are using agile development practices in general across the board. Okay, of course there are some areas where agile development practices cannot be done. Okay, like some of the serious product developments and all. That's okay. Agile is not there to be applied for everyone. Okay, that's okay. So now agile. So how is DevOps fitting into this entire equation? Okay, right. So in order to deliver faster, okay, all these phases, right? So for example, you need to do the requirements collection, design, development, testing, finally the deployment and all this stuff. Okay, if it is all manual, okay, if I am doing one complete integration of my project, like build, integration and deployment of my project in waterfall model, how frequently I'll be doing? Just hardly once in 2 years, right? Even if it is spiral, I will be doing that once in 6 months. But whereas in agile, I need to do, okay, the final release of the project, deployment of the project every 2 weeks. In order to deliver one piece of it, okay, I need to test it 10 times, right? So I might be doing 10 different builds with all the changes and all coming up. Okay, I will be able to deliver only when all the things are tested. So the requirement for someone who can actually integrate all this stuff has increased. The second part is, this is going to take a lot of time. Okay, that means your testing and your integration, your deployment, okay, and your all other security code scanning, whatnot, is going to take a lot of time if you follow the manual process. For example, I'll give you, right? So if you are in this industry like 20 years back, okay, every company used to run a huge QA shop, okay, which is basically, their primary job is, once the code is built, they will be doing various levels of testing, like including the code scanning, right? Okay, for example, we used to do a internal quality assurance, which is IQA, okay, which will be literally manually scanning each and every line of code and then comparing with the coding standards. Did you miss any coding standards or not? That is the first cycle. The second cycle is, there will be an EQA, external quality assurance, okay, where somebody outside of your team, of course within the same company, will come and review your code and they will certify saying, yeah, you have followed all the standards. Okay, now, and this is the way only for code. Okay, after that there will be actual testing onto the systems, integrations, all that. So the testing itself used to take like 6 months sometimes for larger projects. Okay, so which is huge effort. Now, how will you deliver a project in 2 weeks without automating all this stuff? Okay, so DevOps is that thing, okay, which will actually help you accelerate your delivery through Agile by automating all these steps. Okay, except of course coding and all this type. Okay, so for the same example, IQA and EQA, okay, how many of you are aware of Sonar JUnit, which will actually help, okay, the unit testing and code quality stuff, right? So now with the DevOps pipeline, you can simply integrate, okay, these tools, okay, which can be taken care of all this testing automatically. Okay, so like you plug in Sonar with your DevOps pipeline, okay, and you scan your code, okay, for all the issues, okay, and it will give you a report saying that, okay, this is my code coverage, this is my code quality, okay, are you okay to proceed to the next step, or you want to go back? That's simple as that. You don't need a larger group to really go through this testing and multiple days to go through this testing. So DevOps is actually helping, okay, automating all these small steps in this SDLC process, which in turn is actually making agile delivery possible. Okay, I'll pause here, and any questions, take any questions if you have on the purpose of DevOps. Any questions from anyone? Okay, good. So now, what are we going to learn in DevOps? Okay, so for example, okay, there is something called DevOps periodic table. Some of you might be already aware of it, okay, or might be already using this for your reference, okay. So DevOps is not just one tool or one particular product, okay, or just one concept, right? DevOps is basically a culture, okay, and of course you might be seeing some DevOps engineering roles, DevOps tools. Like in general, DevOps is a culture. What is that culture is going to help? The culture is going to help fast forward or accelerate your delivery through agile. Of course, if you need to follow the agile practices, otherwise splitting your entire project into minute release deliverables is really tough if you don't follow agile. Okay, so agile is the core of it, okay, but it is actually going to help agile to deliver faster. How it's going to deliver faster? So if you look at all these things, and I'm sure majority of you might have gone through the chemistry periodic table, it is similar to that one. Okay, so this periodic table, you can just search on DevOps periodic table. And there are these things keep on changing. Don't go with this only this list. Okay, if you come back tomorrow or maybe after a week, there will be a couple of tools that will be added, a couple of tools might be missing, but don't go with the concept. Is what are the areas that we need to look at? Okay, so in general, the areas that we need to look at is, first of all, you need to understand, okay, the entire SDLC process, right? Okay, so the standard SDLC process, okay, is I'm trying to see if there is any whiteboard option here, okay, to draw something, okay. Or let me yeah, use this. So you need to understand first the process flow, then you will be able to get into the tools, okay, easily, right? So the standard way of development nowadays has become, okay, for example, if you look at this particular diagram, okay, you will have, of course, a development team, and you will have testing, either team or process, okay, and usually before production, you always test in pre-production or the lower environments, okay, and then finally, you will be deploying the code into production environments. The typical development, there will be a bunch of developers. Your version controlling tool, okay, so GitHub is one of the tools that we use it for version control, okay. So of course there are a lot of other tools, like right from Subversion to various other tools like ClearCase, Perforce, and whatnot, right? So GitHub being the distributed version control tool and open source, we'll get into these details when we go through each and every tool. What do you mean by distributed? What are the various differences and all this thing? Don't worry about it right now. Okay, so version control tool, basically all the developers will check in or commit their code or put their code into this version control tool or to code repository. Okay, then there will be someone like from DevOps or a build engineer who will be pulling that code. Okay, taking that entire thing into a build. Okay, that means they will build the code, of course, using tools like Maven and whatnot. Okay, so they will build the code and they will actually deploy it, okay, into one of the test environments. Okay, so once they build the code, okay, so once they deploy into the test environment, what happens is, okay, they will be asking the same developers who developed the code first to test for integration. Okay, that means every developer has developed their piece of code. Good. Now everybody dumped their code into one place. Is it really going to work together when they put all the code together? Or do we need to test it? Of course, we need to test it, because obviously, if I test my own Java class and I am calling my previous class some X, but what if that person is using Y as his convention? Okay, that is going to be a deal breaker, right? So we need to make sure individually the code is working, but when we combine this together, is it working or not? Okay, so that's another thing that we need to look at. So that's an integration testing, what we call it as. When we combine all the code, is it really working or not? So usually the way we do is we'll build the code and we'll put the code into a test environment. Okay, that means nothing but a server and a middleware where we deploy the code. Okay, and we will actually be able to test that code with the same developers. Good. Once the integration is all done, that means individual pieces are good, and all it basically it's together, all the pieces are working together. It's good. Okay, that not like the car tires and all these things are get now it got assembled, which is integrated. Now the car is working. Good. Now it goes to, of course, there will be various phases of testing, like where you will be doing testing for regression, performance, and all these things. But I am not talking about all those things, but typical two testings, which is integration. Second one is a user acceptance testing. Okay, so user acceptance testing. Okay, you built my car with all the, like, you built various parts individually, you assembled it, which is integration. You tested it, car is working. Now let's take this car to the user. Okay, now the user need to test against the requirements they have given, of course, right? Okay, so if they are asking for a Tesla but you are giving them a Nano, both are cars but the requirements are different, right? So that's actually what they will test. Okay, so what is my requirement, what is the whatever I have given, okay, and what you have delivered. So that's user acceptance testing. Okay, so same thing, same code base, whatever we have built, that means package. After build, that is called package. The package, whatever we have built, okay, we will be putting in another environment. We call that environment as UAT. Okay, and the end users will come and test, okay, that environment, saying, okay, is the application as per my requirements or not? If it is, they will approve. If not, they will say all these 10 things you need to fix. That will go back to the backlog of your Jira. Okay, and that means your development team. They will fix all these bugs, and the process continues till you get the final stage or final acceptance criteria of your users, right? Okay, so once that is accepted, that product as, okay, this is all good, now you can put into production, that means live. Okay, so once that is all done, okay, then that means once this QA and all this stuff is done, then you will actually deploy your code into generally production, but some environments you can also have a pre-production. Okay, so why pre-production is basically they need basically a contingency environment. Okay, in case if my production goes down, I can use this environment, or I just wanted to make sure I deploy my code into a production like environment. Okay, and do some kind of performance testing before it goes to the production environment. Okay, that's absolutely fine, right? And of course, some of the latest things that right now the industry is using is like blue, green, canary, and all these stuff deployments where it will be useful. We'll go through that later. Okay, what is blue, green deployments, what is canary deployments, and all this stuff. Okay, so they will be doing all these things, and finally they will be moving their code into production. Okay. Okay, so here you can use any cloud flavor, or you can use your internal VSIs, PSIs for doing the deployments. Traditionally, we'll have our own servers, we'll be deploying into that one. Then we'll have, now we are having either private cloud or public cloud, or maybe a hybrid version of it. Okay, so where you will be doing. So deploying into AWS is another thing that we will be learning as well. Okay. So this is the process, entire CI/CD process or DevOps process. So CI stands for continuous integration, CD stands for continuous deployment. we'll go through that one, what exactly is continuous integration and continuous deployment. Okay, so if you look at these, the gray areas and these blue areas, right? For example, if you automate all these steps, like that means if there is no manual intervention from a developer checking in the code, that means committing the code or saving the code into the repository, okay, to all the test results coming back to the development team, the entire process. So that means after checking the code, it's going to do the unit testing, it's actually going to build the package, it's going to deploy into the environment, and then finally giving the results also to you. Okay, there is no manual intervention, it is all seamless. That is called continuous integration. This part, the first section, is called continuous integration. And when you are doing the same thing for deployment, okay, that means completely automated deployment and without any manual intervention into your pre-production and production environments. Okay, so usually any deployment into production, you need a change record. So any company follows this change management policies. I know some of you are working in production also, right? So you know this better, where you will have always this ITSM process in place. Okay, how you will have this change management process. There is a strict rules around, you cannot deploy anytime, you need a lot of approvals, you need right window and all this stuff. Okay, but if your automation goes to a level that all these things will be taken care automatically without any manual intervention, that is called continuous deployment. Okay, there is a term called continuous delivery also. Continuous delivery means there will be a manual intervention only for approvals. The deployment and all will be taken care automatically. That means you will use some scripts or tools to deploy it, but there will be a manual approval that is required before it gets into any environments like production. That is called continuous delivery. Continuous deployment means seamless, no manual approvals also, it's all automated. Okay, so CICD, if you truly implement CICD, okay, there should not be any manual intervention, right from a developer checking in the code to your final production deployments. So imagine this particular entire process, how it is going to accelerate the entire agile development practices. So if you can make this possible, developers don't need to worry about any testing teams, they don't need to worry about their SLAs, they don't need to worry about how many bugs they're going to raise, they don't need to worry about any other environment issues that will occur when they are deploying, or they don't need to spend a lot of nights in general, okay, to do the deployments or to repeat this deployment scripts and all this stuff. It will all be taken care through this CI/CD pipeline. And what is going to make it possible is like tools like Jenkins and all. Of course, Jenkins is only a integrator, okay, where it will integrate a lot of other tools together. Okay, all the each and every step we need a different tool here. Jenkins or Joule, something, those kind of tools will help us stitch all these things together. That's it. Okay, so that is the beauty of DevOps. So if somebody is saying I am able to release my code in agile way, like in 2 weeks, okay, or I am able to deliver my code faster than anyone else, that's possible because they have a solid, strong DevOps pipeline built. Okay, so that's what DevOps is for. Okay, and of course now let's go back to the tools that we typically use in DevOps. Okay, so these are all the tools. Of course, this is not limited to this one. There, if you go to each and every section, okay, you will have hundreds of tools in the market. Okay, some licensed, some actually open source. Okay, some actually partner developed, whatever. Okay, so but these are the tools that we typically. So don't go with a specific tool, but go with the area that we are looking at. So as you have seen in the previous screen, first thing is your source code management, or what we typically call it as software configuration management. Okay, the terminology keeps on changing in the industry, don't worry about it. Okay, source code management, for example, if you highlight this one, the source code management, on the right side, you will be able to see what are all the source code management tools the current industry is using. So Git, GitHub, Subversion, okay, Atlassian, Bitbucket, and all these things. Of course, some people will use combination of Git and Bitbucket, okay. one for repository management, another for source code management. Okay, so these are all the typical tools that is actually right now like well known in the industry. But this section itself will have 250 tools in the industry. Okay, if you ask, or you can just go and search for all SCM tools in the industry, you will get a full list from Wikipedia. Okay, that's different. Somebody put a message. Let me check. Okay, good. So this is the information for all of you. Okay. Now coming back to this one. So what in DevOps, what we are going to learn is, okay, one of each tools basically. Like, so for example, in each area, we'll learn one tool. Okay, that will help us to build the entire pipeline together. Okay, and actually make sure we have a good grip on these areas. Okay, so and on top of it, okay, we first need to understand how the code works. For example, a developer is just developing the code and then putting it in your Git. Okay, as a build engineer or as a DevOps engineer, okay, you need to understand what are the dependencies. Okay, how the code works and what do you mean when the code breaks or the compilation issues are happening. Of course, you need to work together with the development teams. Okay, right? So the DevOps is nothing but that underlying or maybe that center team, okay, which will make sure the development team, the testing team, the QA team or any testing team, and the production support working together. Okay, so you might have seen the typical diagram, a Venn diagram kind of a thing when you say DevOps, right? So DevOps is nothing but that center team which will keep all these teams together. Traditionally, all the phases, that's what we have seen, each phase is used to be developed by one or taken care by one individual team. And they used to throw one, like basically a developer, I'm done with the coding. Okay, let me throw it to the testing team. Testing team, they're done with the testing, they'll throw it to the production team. Okay. And similar thing will continue in every project. They are not taking the accountability or responsibility of end to end for the project. Okay, everybody is just focused only on their particular piece. Now, what DevOps is going to do is DevOps is going to bring all of them together, asking them to work as one team. Okay, so that we can deliver faster. Okay, so that is the beauty of DevOps. Okay, so in order to make that possible, we will use the standard communication between the teams, of course, but at the same time, we use the right tools also to make things automated as much as possible. Okay, good. For example, I need to change a bug. Okay, I need to raise a bug. Okay, as a tester. Okay, the traditional way is I need to engage the developers, I need to put it in their records and all this stuff. That's a manual process. There's a person working, there's a person working on the other side. There will be a lot of debates also. Sometimes the developer says the requirement says like this. Tester says, no, the requirements are different. All these kind of arguments used to happen. Now it's all automated. Okay. So everything will be coming seamlessly from an automated repository, and they just need to take it into their backlog, prioritize it, and then get it delivered. Okay. So coming back to the tooling, right? In DevOps, we are actually going to learn one from each of these areas, starting with the source code management tools, okay, or software configuration management tools, and we will be looking into Git as the primary tool. Okay, that's the first one. Now, the second one, so after your source code management, okay, so what will you do actually? So once you have put all your code into source code management, you will be basically looking at, okay, some tools which will build your code, which is something like Maven. Okay, so for example, where is Maven? Okay, I'm looking at, okay, here. So here it is called as continuous integration tools generally, okay, but Maven is basically a build tool. Okay, it's combined into the CI tools. Okay, you can achieve continuous integration using Maven also, of course. Okay, so if you look at the continuous integration tools, okay, so it has Jenkins, okay, and it has Maven. Maven is basically for build and of course only for Java code. So there are a lot of other tools, and of course there will be some AWS tools also, like AWS Code Build, and there are various tools, Azure DevOps, Codebase, and all this stuff. So we are going to learn Jenkins, of course, one of the continuous integration tools, and for code building we'll learn Maven also. Okay, how to build your code and then integrate that with Jenkins. Okay, so these two tools typically we'll be learning. And after the code is built, what will you do? Okay, so you need to deploy that, okay, into your test environments first, okay, and then you will be able to do the deployment later to production environments, right? Okay, so and even when you are building, okay, the code, so as I mentioned, you need to understand a couple of things, right? So what kind of code you are building? Okay, so is it just normal Java application, or are you building a containers? Okay, or are you able to do some database integration? All these things does matter, right? And also, what is the platform that you are building it for? Okay, so is it a general PSI VSI platform, that means the physical servers or virtual servers, or is it a cloud based platform? Okay, or now there is a new terminology called serverless. Okay, so which is, of course, cloud is making it possible, right? So you need to understand those platforms as well. So you will be learning, okay, a database management, how will you integrate the data, okay, with your entire pipeline. Okay, so that is one important thing. And the serverless thing, so for example, AWS, if you are aware of AWS, Lambda is one of those serverless function. Now the latest things coming up is the function as a service, okay, which make these platforms make that possible. Okay, and also, in order to talk to each and every team within your group, like as I mentioned, development team, testing team, and production teams need to work together. DevOps is the team that will keep all these things together. But there will be some toolings that you will be able to use, like Confluence, okay, Slack, okay, where the communication between these teams will continue. And Microsoft 360 nowadays, or Microsoft Teams, that's actually coming up. That will be another good areas to do this. And also containers, as I mentioned. Okay, if you are deploying your code into a container, okay, or you're building a container, okay, then of course you need to learn Docker, Kubernetes, okay, and you need to learn how the Amazon ECS and all these things are also working. Like you all are aware of Amazon ECS, right? You can spin any number of instances, of course, as long as you have budget, okay, and then ramp up or ramp down your application, okay, dynamically without any manual intervention. Okay, that's also helps a lot. Okay, so these are all the various areas. Of course, cloud flavors, we'll go with AWS. That's what the course says, right? Okay, and but there are various flavors that you can actually look into also. Okay, and usually once the package is built, okay, so we need to keep this package in a repository. Okay, where from this repository you will be able to access this into all the environments. Okay, so all those environments, okay, will be taking this code from only from this central repository. For that, we need to know how the repository management works. How can we look up, okay, all these things. So there are like Artifactory, Nexus, and all these things. We can take one of them, okay, we'll learn one of them, okay, as a repository management. Okay, and first thing, of course, even before your development, you always will be starting with your agile planning, where your Jira and all these things, we will be able to see how Jira works. Okay, how we'll be doing all the backlog refinement, how we'll do the project planning and all this stuff in Jira. That's where it's called as enterprise agile planning. So once you build, you package it, you kept it in Artifactory. Okay, now in order to basically of course, you need to first test it, and there are a lot of testing tools, okay, already available. Okay, and these are various testing tools. Okay, that's like Selenium. I think some of you said Selenium, they have already good experience. Okay, that's one area. And JUnit is a standard unit testing, okay, tool majority of the folks are using. Okay, so all these things, JUnit will by default, it will come. Okay, we will learn either Selenium or one of those tools. Okay, where it will be actually helpful for all of you, right? Okay, and after testing and all, of course, now we will be doing the release or change. Okay, so release management is basically another thing that we always need to follow. So basically what happens is deployment is different from release management. Okay, release management is more around tracking of all the changes that's actually going into your environments. Okay, how will you make sure there are no conflicts? How will you make sure there are seamless releases that's happening into your production? Release success rate is high and all these things. Okay, that's what's called release management. There are various tools like CloudBees and digital.ai, all these things. Okay, now another thing is, for every change that is going into production, there should be a tracker. Like for example, if I'm just pushing all my changes into production without any tracking, like who made the change, what got changed in my production, if something blows up in my production environments or something went wrong in my production environment, I will not have a clue what went wrong, what particular change caused this particular issue. Okay, so I definitely need a tracking. Okay, for anything. So that's what's called ITSM. Okay, IT service management. Okay, and that's where we will track all the issues. I think this is where some of your production management folks will be aware. Service now is actually the one that's really now like very high in the industry. So we'll learn service now and how service now works. Okay, especially from change and release perspective. Okay, we'll not go deep into the incident management, all the stuff. We'll take few modules of ITIL. So if you are familiar with ITIL, so here we'll focus only on the change management module and release management. Okay, we will not focus on the incident and other stuff. Okay, so that's service now here, and we looked at all other stuff like release management, all these things. Okay, and another couple of areas that we also need to look at is DevOps is also called as Devsecops. Okay, so DevOps is I think now a lot of people have started calling this as Devsecops. Okay, so why DevSecOps? Because the security element is another element that we cannot ignore. Okay, how many of you are aware, who, especially the folks who are working already, of the Log4j issue that's right now shaking the entire industry? Anyone?
Yeah. Yes. We came to know like 5 days ago.
Okay, good. Yeah. So if you are aware what's that issue, it's basically a vulnerability which Log4j has, and only after basically the 2.x release, right? Okay. So that's actually area we usually ignore, okay, when we are building software. Okay. What kind of issues that my software may have when it goes to production? Is it prone for hacking? Am I opening too many loopholes for the hackers or anyone outside get access to my code or get access to my company assets and all this stuff? That's why we need to do a scanning for security of your entire code. Okay, you can call that as SSAP, or you can call it as vulnerability scanning, anything. Okay, but there are tools that will help you scan your entire code for all the known vulnerabilities, of course. Okay, and that will help you to make sure you build the code right, you integrated the code right. Okay, and you have built the code for as per your user requirements, but have you built the code more securely? Okay, or is it going to be secure when you put into production? That's another aspect of security that we need to look at. Okay, so we are going to integrate the security aspects as part of our DevOps pipeline. Okay, that's why it is called as DevSecOps. So what is that we need to do in order to integrate security, right? So definitely we need to scan our code with any one of the tools, right? Okay, so there are a lot of tools. Okay, so in this particular view, they included Sonar Cube also, code quality aspect also into security. But normally we use something called Fortify or Black Duck, something like that, Raven. These are the various tools, okay, that will actually help scan all your code for various vulnerabilities, okay, and help you detect if there are any vulnerabilities in your code. Of course, it will rate high risk, low risk also, and you can take a call whether you want to move forward or go back and fix those vulnerabilities before it gets into production. Okay, that's another important aspect of DevOps. Okay, that's why it's called DevSecOps, not just only DevOps. Okay, and
Excuse
another
me,
area.
one second. This is Mallikarjun.
Yeah, Malcolm.
See, actually, DevOps means within the cloud only we can able to do anything, or without cloud we can't able to do anything.
No, you can do anything without. See, cloud has become live recently, right? Like hardly you are hearing about cloud like 5 years, okay?
Yeah.
And DevOps is there for almost 15, 20 years, okay? So you can do DevOps even on your local system, okay? Or your physical servers or your virtual servers. So cloud is just one of the environment options. Like for example, once I build my code, my package, I can deploy the same code into my local server or my virtual server or to cloud. Okay.
Okay.
So cloud is
Okay.
just an environment actually.
Okay. Okay.
Why we use cloud is more around, okay, around my computing costs or my resiliency and all this stuff. Okay. So cloud is just one of the environments for us. From DevOps perspective, it's just one environment for us. Okay.
Okay.
Yeah. And that environment can be anything. It can be cloud, it can be on-prem, it can be anything.
Thanks a lot.
Okay, cool. So yeah, when you look at the value stream management, okay, these are the areas, okay, where we can actually get some kind of a lab environments for your integrated testing. Okay, sometimes even though you don't test any functionality, you will be testing the configuration. Okay, you will be testing some of your connections. Okay, that's where it will actually help these particular tools. Okay, these are not like so important for us, but in general, if you want to really leverage these kind of areas in your organization, you can use this kind of tools. Okay, another such tool is basically AIOps, okay, analytics. So here they have combined the monitoring tools also under AIOps and analytics. This is another important thing. Okay, integration of monitoring tools is required for us. Of course, if the company is really focusing more on the monitoring stuff, okay, like if they're heavy on using the Splunk and monitoring tools, if they are using good SRE practices, of course, okay. So SRE, by the way, is site reliability engineering, okay. If they're using good SRE practices, they will definitely invest on the monitoring heavily, okay. So here, from a DevOps perspective, our job is, okay, if I am putting a code, okay, onto production, I need to make sure I have some kind of mechanism to monitor my code, to monitor how many users are actually coming in day out, how many user transactions are successful, how many users transactions are failing. If these kind of details are required, so you need tools like Splunk, Dynatrace, and all these things, right? Why do you need? If you monitor only, then you will be able to see if your customers are actually able to go through all the transactions, or there is high rate of failure, or how can I really help them to make sure if there is something wrong. Okay, so monitoring is another aspect. Now, why it is called AIOps? Because monitoring tools are now matured in such a way that they are using all the historical monitoring information to really predict some future failures also. Okay, that's why it's called AIOps basically. So they have those AI modules built into their products. Okay, that's why it's called AIOps analytics tools. Okay, so but our job from a DevOps perspective is how we integrate these tools as part of our pipeline. Like when I install my code, am I installing my monitoring also, or am I enabling the monitoring? Usually the agents will be already installed on the servers. Okay, but can I make sure I have enabling this monitoring for the piece of code that I have deployed, or for the application that I have deployed? That's another piece that we will be integrating. Okay, so these are all the various areas we will be learning, okay, as part of DevOps. Of course, we will start with the basic thing, how we will work in Agile and how we will code. And from that code, we'll take it to how we'll save the code into source code, how we'll build the code using Maven, how we integrate all these pieces using Jenkins. Okay, all these things we'll learn one at a time. So it's definitely going to be a interesting effort. Okay, and it's not easy to learn so many tools, okay, in just short period of time. But as a DevOps engineer, our focus is going to be not administrating any tool, okay, but integrating these tools. Okay, keep that in mind. Okay, so we are someone like a mechanic who's going to fit all these things together. Okay, but not a engineer who's going to fix the engine. Okay, so that's the analogy I can give. But if you are interested, for example, you want to master any of these tools, okay, that will actually give you that deep knowledge in any of these tools, which will actually help you to get into an administration kind of a role also. But that will be a different discussion. Okay, so I'll pause here. I'll take any questions before we wrap up.
Excuse me. See, how much? What is the timeline for this course? Could you please let me know?
So we are planning around 45 days, like that.
45 days.
Yeah, and one to 1.5 hours a day.
Okay, what is the timings of this course?
The timings, I think it's already pasted on the chat here. 7 a.m. to 8 a.m. IST.
Say 7 a.m. to 8 a.m. IST.
IST, yeah.
Okay.
And
Okay,
of
what
course,
see you people give any kind of means environment to whatever the tools you can give just a live examples you can provide all those things.
yeah, so you will be using your laptops, and I'll walk you through how to install all these tools, and then how you will be able to achieve. Of course, you will be putting your AWS account also. It's a free account, 750 hours with your email ID. So we'll be creating that account, and we'll be using that environment for deployment purposes. But rest all on your local.
Okay, thanks a lot.
And how many hours is the course daily?
1 hour. It may sometimes go 1.5 hours.
And do you also take it in the weekends?
No, only weekdays.
Weekdays. Okay. Yeah.
We can decide in case if everybody wants. Sometimes, if I'm free, we'll be. Okay. Any other questions from anyone?
One more thing,
question.
is there any way to get? Sorry. Go ahead, somebody. Okay.
So DevOps and what is the difference between DevOps and SRE?
Okay, that's a good question. So, site reliability engineering, SRE. Okay.
Yeah.
The way I look at DevOps and SRE is basically, in DevOps we talked more around delivering from development to production. Okay. After maintenance, we did not talk about, right? We said, okay, maintenance is the last phase. Production team will
Yep.
take it. Okay. But
Yep.
if you look deep into what production team will go through, okay, I know some of you are actually into production, right? So they will have
I'm from the production
lot of
support.
incidents.
Yeah, that's
Sorry, there is some background
yeah.
noise. Okay. So usually once it is into production, any application, okay, you will have day-to-day issues, like you will have incident, you will be making changes, which is like deployment of new changes, and you will have some patchings for your environment. Okay, you will
Yep.
go through various issues, right, on a day-to-day basis. Now,
Yes.
how are you going to basically reduce this number of issues? That's the first point. If an issue occurs, how fast you will be able to react? So usually that is called your
Okay.
MTTR, mean time to repair or restore, right? Okay. So
Yes. That's correct.
that's what is required for your production management. Production management teams always needs two things: how fast you can react if there is an incident. Second thing is how to make sure there are no issues at all. That will be nirvana for them. Okay. So SRE is going to
Okay.
make it possible by doing various things. Of course, SRE will also have various dimensions to it. First of all, automate as much as possible, reduce number of
Yeah.
manual interventions. That's the first motto, which in term, basically in SRE terminology called as toil reduction. Okay, that will be the first area
Okay.
of focus. So in order to become an SRE, you need a lot of automation, especially scripting. Okay, and you need to
Yep.
know tools like Ansible, Chef, Puppet. Okay, and all these things, right? That's another area. Okay, that's the first one. Second one, in order to reduce your MTTR, okay, which is your mean time to repair. In the mean time to repair, again, you will have 4 different sections. First thing, how fast you are able to identify that there is an issue, okay, and how fast you are able to track where the issue is, okay, and how fast you are able to fix it, and how fast you are able to mitigate it permanently. Okay, so these are the 4 areas. So each area definitely needs different set of tools. For example, if you don't have any monitoring enabled, you will not be able to identify any issues before the user, right? So first, monitoring is another huge area that you need to invest in SRE. Okay, and if there is an issue, how fast I can mitigate? Usually any issue mitigation will definitely take some time, but if you have a resiliency environment like cloud, okay, you can switch to the working environment, and then you can start fixing the non-working environment, so that the end users are not impacted. So that is another area. So resiliency is another area that we will focus, which cloud will help you to make it possible. Okay, and
Okay.
there are various other things like non-functional requirements, like you need to make sure you have proper logging standards. You need to, and DevOps is also another aspect of SRE, by the way. Okay, for example, change is another painful thing for all the production management folks. Okay, if those changes are all automated, then you don't need to really worry about scheduling a change, manually deploying it, and then going through all the pain points and all this stuff, right? So change automation or deployment automation is another thing that you can also focus in SRE. Apart from this, there are various aspects like chaos engineering. Okay, that's another huge area that's actually evolving now. Chaos engineering is nothing but you are going to put your production environment through a massive basically testing. For example, if I am going into my server room, pulling out a plug, okay, pulling out a cable just like that, will my application survive or not? Can it automatically go to a resilient data center and then survive or continue serving the people? That's one example. Or if I intentionally kill a particular instance, okay, will automatically the EC2 instance AWS will automatically open up another instance and then continue running my application. These kind of testings will be done in chaos engineering so that in the real-time scenario, anything can happen, right? Okay.
Sir, could you please spell it out again, sir? Sorry. What is that? Chaos engineer? Something you told right now, right? What is that engineering? Chaos engineering.
Chaos engineering, CAOS. Okay.
Chaos
And
engineering. Okay.
even in the deployments, we can talk about canary, blue, green. Okay. These are various deployment flavors, right? Okay. So canary, in the sense, what happens in canary is that, okay, you will not deploy, you will deploy your code in general for all production environment. Okay. But the end users, the feature will not be visible for all the users. For example, if you take in your HDFC account or anything, sometimes you might be observed like you and your friend both are using that application, but there is a particular feature open for you only, not for your friend. Okay. Why is that difference? Is because they might be practicing canary deployments. Like you deploy the code, but you're enabling that feature only to a particular small set of users, like 5% or 2%. Once that is enabled, they will wait for any reactions or any issues from that user set, or they will rigorously test that. Okay. Once that is all good, then they will open that feature for the rest of the people. Okay. That way, even though something goes wrong in production, the impact is not for 100% of your users, only to those 2 to 5% of users. Okay. That is the advantage of canary deployments. Another thing is there is something called blue-green deployments. Blue-green deployments are like you will have a parallel environment, like just like the pre-prod and prod environments. You can call one as blue and one as green. Okay. So what happens is I will deploy my latest code into my current testing environment. Okay. And once all the testing is done, I will switch these environments in such a way that my testing will become production now and my production will become testing. So in the next cycle, I will actually go and test all my new code into this new production, the legacy production environment. So I will switch the environments, rotate the environments like that, okay? So that my end users are not impacted. So in case if I switch the environment and there is something wrong in the production application, I'll switch it back easily, okay? So the blue-green advantage is that. But here, you will be switching for 100% of the users, okay? So whereas in canary, you will be just putting only a percentage of users, very small percentage of users live, and then you will wait and then actually roll out for the rest of the set. So these are the things that we'll practice in SRE. Okay. Any other questions?
Okay. Thank you. Yeah.
Yeah. SRE usually will take it as a separate course because that's a huge dimension. You need to go deep into various, and coding is also like two other things that is very important to become an SRE. Just for your information, I'm giving this. Okay, you must have some kind of production experience. Okay, of course, some people will say it's not required, you can learn. Okay, but production experience is actually a very good thing to have if you want to become an SRE, and you have some coding experience also. Like look at these two things, two different ends of SDLC. Okay, one is the development side, second one is completely operation side. SRE is saying you need to have these two, okay, along with all the tools and everything. Okay. So that means SRE is expecting end-to-end knowledge on the entire SDLC, okay, and experience also, hands-on experience. So that's what will take you to SRE.
Excuse me, sir, I have one doubt.
Yeah.
See, actually, for this DevOps, whatever the course we are discussing, is there any certification is there? Right now, what we are discussing now, certification is there for DevOps?
Okay, I would not recommend any DevOps certification because there are some companies that is providing like DevOps Master. Okay, and
Okay.
there are like Udemy and all these folks are actually providing DevOps certification, but
Mhm.
don't take them as very in-depth certifications.
Sorry?
Like for example, if you take a DevOps Master certificate, majority of that certification is around like they will ask around 50 different theoretical questions. Okay, and they are
Mhm.
pretty basics. Okay,
Mhm.
and I don't see much value in the industry for those certifications. Whereas I would advise you guys to do, like for example, AWS certification individually, Splunk and Dynatrace certification individually. Okay, those kind
Okay.
of certifications will help.
Okay.
Whatever the tools you are using, every tool has their own certification. Okay, like for
Okay. Okay.
example, HashiCorp. Okay, and Kubernetes if you are learning. Okay, there is a prestigious Kubernetes certification, CCAD. Okay, so if you are
Okay.
certified CCAD, anyone would ready to take you into any Kubernetes team. Okay, because it's really
What is
tough
that,
one
sir?
and hard to get.
No, what is that, sir? You told just now.
It's called CCAD, CKAD.
CCAD. Okay.
Yeah, that's
Okay.
only for Kubernetes, by the way. Yeah. So each and every one area has its own certifications. I would advise you folks to do that rather than going through this DevOps masters or anything. Okay? Of course, if you have time and energy, go ahead and do it. It will help. Okay? But in general, in the industry, I don't see much value to any DevOps certifications.
Okay.
And even SRE, there is no standard certification in the industry right now available. There are various training companies coming up with some kind of certifications, but I don't recommend in general, okay, those certifications.
Okay. Okay. Thanks, sir.
Yeah. Yeah. Any other questions from anyone?
Yeah, hi sir. This is Madhu. I have one
Sorry.
query, sir. Sir, actually, so what is the pattern like that we're following? Like, no, are we walking through the AWS components, or like, are we going to the first component? Like, example, if are we can we say that we are going to be familiar like each component? Like, suppose we have a GitHub, so can we be master in that GitHub, and later we can go forward into the AWS component? Like, how we are going to deal these things?
Yeah, so that's a good question, Madhu. So we will be going through each and every tool. Okay, we will be spending a couple of days in each and every tool. Okay,
Okay.
and as we go, we will be integrating each of these tools into our Jenkins pipeline. We'll take a sample application, okay, sample Java code, okay, and
Okay.
we will see how we'll check in that code, check out that code into Git, okay, and we will talk about various aspects of Git, how Git works and all, okay, and how we'll integrate that into your Jenkins pipeline. Okay, all these things we'll talk about. Okay,
Okay.
so for
It's not
example,
only. Okay. Yeah.
sorry,
Continue.
yeah. So for example, if you wanted to become, for example, AWS, let's take AWS. You want to become an AWS solution architect. Okay, we will not be able to do that because that will take more time. That itself is a course. Okay, and each of these tools, as I mentioned in the earlier dialogue, you can master each of these tools. Okay, but mastering is going to take its own 45 days time. Okay, what we are going to focus is on only the CICD pipeline. How are we going to create the CICD pipeline? How are we going to make sure all these tools are working together? Okay, how we integrate these tools so that end user knowledge, integration knowledge, okay, how to use this tool, where it will fit, that will come here. Okay, administration level knowledge, it will take more time. I'll be happy to help in case if anybody is interested to go deep into any of these tools. Okay, but for this course, okay, we will be focusing only on the DevOps
Yeah.
part.
Yeah, that's true. So it means like, so can we hold a good practical knowledge like with respect to the GitHub or Jenkins or
Yeah.
Kubernetes or Docker containerization? So like,
Yep.
is that going to be helpful in our industry practices?
Yeah, so if you are applying as a DevOps engineer, okay, all these tools, knowledge, and integration is good enough actually in the industry, okay. And if you want to become an
that's true. We
AWS
can't.
solution architect, that's a different story. Yeah.
Yeah, that's true. We can't be a administration within 45 days, but at least if it can help us in like to fulfill our industrial
It
practices.
will fulfill the industry expectation for DevOps. Yes.
Okay, okay, sir. Right.
Hi. Do you have any any real-time projects so you can give guidance so we can go for in future and we can have it?
Yeah. So real time in the sense as you know, okay, it will be real time for someone in the past. Okay, it may not be real time right now. Okay, but
Yeah.
yes, I'll be showing some examples. Okay, around how it works in various, and there are some good DevOps architecture references, which is standard architectures, DevOps architectures basically. Around 60-70 companies. I will refer to that one actually. How each company is implementing their DevOps pipeline, okay, and all this stuff. Okay, but I cannot get the real-time code from any company.
No.
Okay?
Means every company has their own style, but means like at least we need to have some basic after learning this, and when we are doing the real time, so we should not hit
So
any.
we will be doing our own hands-on, okay, on a sample code, of course. Okay, that sample code can be anything. Okay, we can actually get a real-time code, or we can get some dummy code. Okay, but even though we say it is real-time, it's not actually used by that company right now. It might be a legacy code.
Yeah. Okay. All right.
Yeah.
Okay. Thank you. Thanks.
Yeah. Okay. Any other questions from anyone?
I'm good
Okay.
from mine.
Okay. Good. Yeah. Thanks everyone, and wish you all the best.
Yeah, thanks a lot.
Yeah. Thanks a lot for your